Well, good morning, everyone. How are we today? How is the conference so far? I can't hear anything. How is the conference so far? Okay, let's put some energy in the room. Um, I'm, I'm Eliano Marques. I'm from ThinkBig. It's a great pleasure to be here and walking you through a process more than anything else. I'm a senior data scientist, and I've been in this field for a while, about 7 years, in helping many different business organizations of multiple sizes, making the best out of the data, right? But what I will walk you through, what I'll walk you today, is what we have figured out that was a good way to bridge the connection between the business, the analytics teams, and the IT teams, okay? Because sometimes we talk about generation of insights. We just heard about prescriptive analytics, but there is actually a very difficult step to actually link the entire thing together, okay? So that's what I'm going to do today. Throughout this process and throughout my conversation, I'm going to walk you through a use case around predictive maintenance, okay? Because it's a good use case to actually explain how do we go from insights to the validation of those insights before we put it on large-scale production. Is that okay with you all? Okay, great. So again, we're going to talk in a couple of things, very high level on architecture, a little bit of experimentation, what about time to fail models, risk to fail models, but it's more about understanding the process that I'm here to explain. I really like to insist in the idea that a large-scale environment, a large-scale solution needs to be incorporated into the analytics strategy, the big data analytics strategy of the organization, right? Because if it's not really part of that strategy, it will be disconnected. It will be a one-off exercise that you do on a business department that never leaves that department. And if you do it as part of the strategy of the organization, you will see that the next big thing that is really important to achieve, as I said in the beginning, is the linkage between the business, the technology, and the analytics. So for us to be able to go from an insight to a production environment, we need to figure out a way of working around that triangle. Okay? Which is very, very, very important to work around that triangle to make sure that the solution is not a one-off exercise, it's part of the strategy, it has a linkage to the business, and it generates the value that they are expecting. So how does this exactly start? Well, this starts, and I'm walking you through this process and being a little bit detailed about it, because that will drive the rest of the presentation and then the use case, okay? So this all starts with planning, with roadmap, business analytics roadmap, which is all the different departments that want to be served by analytics and IT speaking together and defining what exactly is the ideas and the use cases that we would like to explore over the next year, over the next 2 years. Some of those ideas had a lot of maturity into it, but there are others that are just ideas that they would like to test to see if there is value. At this point in time, you have no idea if any of those use cases will ever reach a large-scale production environment. You just don't know. And companies think sometimes that they have an idea and they're ready to go to production. And they go to the IT and, hey, here you go. Can you put this in production in 2 weeks? Thank you. And then you go away. And then you come back 2 weeks after, and you don't know what you have done. And you're using your IT resources to do machine learning experimentations. Oh, because they can run some scripts. Or, for example, the business doesn't recognize that for you to go from a use case to a production, you need to understand the value of any model. We just heard about the prescriptive analytics. Well, does that have any value? What's the cost of implementing that? So it's very important that these roadmaps actually get well defined and prioritized, as well as doing the experimentation well. Experimentation in our case may be online or offline. In other words, it might be a case where for you to go through an experimentation, you need to join forces with the production team if you have a recommendation engine and you need to add a new model to the A/B testing framework. That data needs to go into production, so you might need to involve the production team. Sometimes you don't. Sometimes you just get the data and you essentially start doing an exercise, testing hypotheses. And we're going to walk you through that in a second. One step that we keep seeing companies forgetting about is actually doing the validation after the experimentation. Okay? Companies think that a model, we just predicted that it's going to rain, so take the umbrella. What is the cost of that? Do I need to buy the umbrella? How long it's going to rain? 2 minutes, so I'm going to buy an umbrella that costs 10 euros to be 2 minutes under the rain? How strong is the rain? What's the value of getting the umbrella out? Do I have space in my bag to take it? Okay? So it's important to do this validation and to be the business leading the validation, not the IT department, not the analytics department. It's the person that wants to put that idea and that use case into production that needs to lead that process and ask the production team how much this will cost to go to production. Do I need to create a new ingestion pipeline? Do I need to create a new architecture? What's the change? What's the gap? And then what's the value of the business to do that? And then, of course, let's assume all goes well. Then you're ready to put the solution into production. So what I'm going to do now, this is too theoretical, but what I'm going to do now is I'm going to walk you through a use case on predictive maintenance. It's based on X amount of projects done in this area, just for you to see how do we go from insights that we generated through experimentation right through large-scale production environments where you take continuously the value out of the solution. Is that okay? Great. So again, let's start by assuming I am one of those individuals, a CFO, a director of assets or production, and I want to understand in the next 5 years, where do I going to put my money to replace assets that cost a lot of money, okay? It's a very traditional question that a director or a CFO has. I have a big network or I have a production plant and I need to invest in capital. I need to replace the technology. I need to replace the assets. Where do I do that? Second big question could be, how do I prioritize the investments? If I'm going to make, let's say, on a gas network, for example, if I'm going to replace 10 pipes, which one do I do first? Okay? Do I have resources to do that? Which ones do I go first? It's a very typical problem as well. If I, instead of investing 100 million pounds in my network or in my production plant, invest 98, what's the cost on the reactive maintenance? What does that mean from a reactive cost perspective? So this is like typical questions that you think, is this related to big data? Is this related to analytics? Yes, absolutely. Let's see how. Director of operations, how does he predict demand? How does he predict demand for parts, for stocks? Okay, think of a production plant full of sensors producing data every mile of second. You need to predict which parts are going to break, because if you predict which parts are going to break, you might be able to buy the stocks before you run out of stocks, reduce downtime, increase production. So how do you do that? How can you go to a director of operations that has no idea of what a sensor data means, has no idea what a big data solution means, has no idea what a predictive model is, and try to explain how it is? So kind of big steps for them to actually go and understand. And then you have the people in the field engineers that are willing to understand. I wake up on Monday, I go to work, it's 9 a.m., I have 1,000 faults. Where do I go first? How do I help the engineer that is going to the production plant or to the network to actually clear a job to make him more efficient? Can I use analytics to send something for the app that is going to the field and help them identify where the problem is first? So when he arrives in the place, he reduces the time of understanding where the problem is coming from by 10 minutes to a minute, or by 2 hours to 10 minutes. And that way, you can do more jobs in the same time. So all of these things are totally related with a big data analytics platform, totally related with analytics, but it all starts by this gentleman speaking to us, speaking with IT and saying, I would like analytics and big data to help me answering those questions. So in this particular scenario, We would start by trying to go through a process of experimentation where we would sit down with the business, sit down with the IT owners of the data, and run some workshops to define which hypothesis we're going to test. I have here some examples at the end of three main hypotheses that we went through, just to give you an idea of what would be a real-time big data platform, a batch big data platform, and then somewhere between those two, just to give you an idea of how we do the linkage between an hypothesis to a big data architecture and then go to production with it. So again, we would define the data, we would go through the experimentation, the testing. We typically involve at this stage data engineers, data science. The production team may be involved depending on where the data is coming from, where do we need to test the experiment, and then the business owner that will run the experiment. I mean, I think this is quite clear for you. We'll have some workshops, we'll do the checks on the experimentation. I'm really keen to go through the hypothesis, which is what will make you understand the complexities of the solution. So let's see the first hypothesis that is around how do we create different capital investment strategies. Again, we would need to, in this specific case, build some target investment models that require a lot of historical data, and you would put a scenario tool on top, which means a user would be able to kind of make tweaks on the data, press a button, run large-scale models, essentially models that may take 1, 2, 3, 4 minutes to run, and come back with some answers about how much team you're going to need, how much investment you're going to need to make, where do you need to go, and what you need to do. These models are not something that needs to run in real time, but they need to run in batch. You might need to reschedule this to run every day or every week. And the data that supports this process is essentially pretty much all the data that you have from operations, from workforce, from failures, and from stocks. So it's a big, complex model that sits under the hood, but it doesn't require real time. You don't need to respond on a failure that just occurred. Okay? This is for a CFO, for a director of operations that wants to control the business, wants to make decisions, but long-term decisions, mid-term decisions, not what's going to happen right now. Okay? You do the experimentation, you come up with a tool, you share with them, and say, well, change this, change that. Is this ready to go to production? Is this ready for us to create all the process and link the underlying process to go to production? Hypothesis number 2, where you really need real time. Can you use sensor data to predict time to fail or risk to fail? Very good hypothesis. So you would grab all the data from the sensors, let's say second data or 1 minute data, and you would come up with models that try to predict when the asset is going to fail, where is the risk of the asset to fail. And then you would put that risk, that prediction, in the hands of the field engineers for them to make decisions. Okay, this is about to fail, let's buy some stocks. Or, okay, this is about to fail, let's stop the machine now, let's clean it, and let's put it back on. Okay, so all of this requires real time for two things. The sensors are generating data continuously, and the field managers, the field engineers that are on top of their network, on top of their production plant, they need to react instantaneously. So what this means is, while I can give you a model that does that prediction effectively, what is the cost of putting a real-time system in production? Because it might be a situation where you need to measure both from a benefits and cost perspective. And then finally, the other one, which is a middle step between real-time and batch, where essentially you would generate faults. Network and production plants always generate faults. You would then try to come up with some models that would predict the root cause of the failure, and then share that root cause directly with the field force that is going to do the job. So when they arrive, they do their job faster. Instead of going to a place, I know there is a problem with my computer, I just don't know where to start, they would be receiving information on an app or on a phone, which will tell, well, the probability of being there is 80%. The second highest probability of being there is 60%. Where would you go first? Probably there. So it's kind of trying to help the field engineers to reduce that gap and try to act faster. Okay? Well, all of these three hypotheses, all of them are suitable to go to production. are suitable to generate insights. Which ones generates more insights, lower cost, which ones generates the fastest process to go to production? Those are the questions that each experiment owner, this is free experiments, would have to decide with the business, IT and analytics team and actually act on that. So I just want to walk you through very quickly the validation process. This process is typically a 1 to 2 week exercise. Now you gather all the inputs from the experimentation. You know how much is the benefit for you, what's the size of the pot, how much you can actually generate with that experiment. Next thing you need to do is to sit down with the business, sit down with IT, and measure the costs of putting and changing the technology under the hood to put that into production. And after those 1 or 2 weeks, you come up with a workshop where you have the steering committee and you will present in that session, hey, I would like to put this into large-scale production. This will cost me 10 million pounds, but the benefit over the next 2 years is 50 million pounds. So we should do it. So that's exactly what this next step in this validation process tries to do. It tries to come up with the three important steps to make a decision around this need to go to production, yes or no. What kind of steps I'm talking about is the technology costs and changes in the architecture assumptions that needs to come from the production and the IT team, side by side you, very agile process of interacting with them on a day-to-day basis. The business have to produce the assumptions to the benefit that that will generate, because before you did the experimentation, it's just an idea. You may have some thoughts, you may have some assumptions, but now you have the analytics to show you what the benefit would be for that specific experimentation. And then you do the business case. Is that clear so far? Yeah? Okay. I'm trying to look at the time and try to achieve all the steps with the time. Again, finally, this process is really very IT-driven, very engineering-driven. It's essentially based on agile principles, where essentially you receive the experimentation, you receive the business case, and you come up, you essentially divide that into an agile process to actually put that into production. Okay? I'm sure majority of you are familiar with this methodology, with Scrum Master, with Agile principles, but essentially what we try to do is we try to run sprints and run cycles of essentially 2 to 3 weeks and try to productionize the solution step by step, taking into account what's already there, what's already in production, not trying to cause as much as disruptness into the current process, into existing process. So in this case, of course, I mean, think of, we are essentially saying, can the sensor data be productionized? Yes, it can. So what we're really looking into do is finding the best architecture that will enable that solution to be put into production. We have here a reference architecture that we typically use. It's very high level. It doesn't show all the pieces of the ingestion. It doesn't show all the pieces of the models are in production, the modeling publishing framework. I just wanted to give you a little touch about how to go from insights to production with a specific use case. This process is very important. We see day and day, like every single day, companies not thinking correctly about this process and trying to go from 1 to 4 directly, or sometimes trying to go from 1 and then they say they are in 4 and they are doing experimentations. And that kind of steps and solution for us has been quite important. So in this case, you would have now a solution. This is based on real projects that we have completed. It's essentially saying, well, now you would put a predictive model in the hands of the field engineers based on top of the sensors that will enable you to make actions, rather buying stocks while stopping the machine, trying to understand faster where the issue is coming from and act on that before it's causing you a bigger issue, essentially. That's really it from me. I really wanted to kind of pass this message about these 4 steps, about the methodology to go from insights to a large-scale production environment. keen to hear any questions that you may have, keen to understand if there is any particular element of the process that you are really interested. If you don't manage to make those questions now, I'll be outside, so you can always come and speak to me. Thank you.